Hey everyone, so today we're covering moles for the chemistry unit 5. Let's just get right into it. So the moles unit, or the Stoic questions, are very calculation heavy. There are some concepts in here I'll cover, but it's mostly just formulas, plug and chug. So I won't spend too long on this review, but yeah, let's just get right into it. So the first one says, show a numerical set for calculating the percent composition of mass of silicon and silicon O2. So pretty straightforward. So the equation for percent comp is just, let me pull over here. It is mass of part over mass of whole times 100. So for this question, we can just have the mass of the part, which is the silicon, over the mass of the entire thing of silicon O2 times 100. And so that is the numerical setup. You don't have to write your answer, but you can. You won't get dot points for that, obviously. But yeah, pretty straightforward. So let's move on. Number 2. Determine the total mass of ethanol produced when 270 grams of glucose react completely to form ethanol and 132 grams of carbon dioxide. So this one I'm actually going to do out over here on the side because it is like more traditionally a mole question. So the first thing I like to do is just say what we start off with. So we have what happens when 270 grams of glucose react to completely form ethanol and 132 grams of carbon dioxide. So 270 grams of that glucose. Now I like to put this over 1. All right, because that's our first bracket here. And now we're trying to find the total mass of ethanol. And ethanol is this thing over here on the products. And so in order to get to that, we need to first convert our glucose into moles. So we have 270 grams of glucose, so we want to find how many moles that is. So the gram formula mass for glucose is 180 grams. All right, and then we can just put 1 on top for 1 mole. You'll see the reason I'm doing this is because the grams on both sides cancel. So this is how you know you're on the right track. And so you're left with moles, and so this part of the equation here will tell you how many moles it translates to. But the next thing we want to do is just find the ratio. So we can see that there is 1 mole of glucose, which produces 2 moles of the ethanol, right? So now we just want to convert this. So 1 mole, and then we can just put this over that ratio over 1 mole. So now we're saying that for every glucose mole we produce over here, what we're going to get is 2 moles of the ethanol. And so now we know how many moles of ethanol we have, so we have to convert those moles of ethanol into grams because that is the total mass. So the gram formula mass of ethanol is 46 grams. We put that on top because 1 mole will cancel with the units. So you'll see here, moles cancel with moles, moles cancel with moles. And now we're left with our final answer of 138 grams. And we can see right here. So yeah, I made sure to spend time on that because that's more traditionally the harder mole concepts of just multi-step layered questions like that. All right, number 3, determine the molarity of this solution. So molarity of the solution, the equation, we'll just pull that out. Molarity is moles of solute over liters of solution. All right, so how many moles do we have here? It says in the equation that this 2.5 liter aqueous solution contains 1.25 moles. So we have 1.25 moles on top, and then the second part of the equation is just the liter of solution, and so we just have 2.5 liters on the bottom. So 1.25 divided by 2.5 gives us 0.5 mole. All right, number 4, write the empirical formula for absorbic acid. And it says absorbic acid is also just vitamin C. It has the molecular formula of C6H8. So write this out. C6H8O6. So the empirical formula is just the most condensed, simplified version here. So let's find a common factor between all these. We can divide each of these by 2, right? Simplifying 6 divided by 2. So it gives us 3, and then 8 divided by 2 for the hydrogens gives us 4, and oxygen is the same thing. And so now these don't have a common factor anymore, so that is the most condensed version, which is our empirical formula. Number 5, show a numerical setup for calculating the percent composition of mass of oxygen in absorbic acid. So very similar question to number 1. So we'll just find the total mass of the oxygen, which is 96 grams, over absorbic acid, which is this formula over here. So you can add that up, but I will tell you that it is 176 grams. So that gives you number 6, determine the number of moles of vitamin C in an orange that contains 0.071 grams of vitamin C. So we have 0.071 grams, and we're trying to find how many moles that is. Well, we know that the gram formula mass is 176 moles per grams per mole, right? So we can just set 0.071 over 176 to find our number of moles. So you'll see here, I did a little differently here, but you can see it's using the similar setup to number 2. All right, number 7, in the space below, calculate the gram formula mass of glycine. Your response must include both a numerical setup and calculated result. So glycine is this formula up here, that organic compound. So pretty straightforward here. We're just going to literally just add, we're going to find like nitrogen on the reference table, find its mass, hydrogen, carbon, etc. So it should look something like this, and you should get 75 grams as your final numerical answer. All right, number 8. So we have hydrogen peroxide as a water-soluble compound. The concentration of an aqueous hydrogen peroxide solution, that is 3%. Let's underline that. 3% by mass is used as an antiseptic, and that's the equation for it. Calculate the total mass of H2O2 in 20 grams of an aqueous H2O solution that is used as an antiseptic. It must include both the numerical setup and calculated result. So this is to find the mass here, because they give us the percent composition of by mass, which is 3% they stated. We can just use the same equation we did before with percent composition of mass equals mass of part over mass of whole times 100. So we have the percent composition, which is 3%. And then what we're trying to find is the total mass of H2O2. So that would be our part, because our whole is just the entire solution, which is the aqueous H2O2 solution where the septic has been dissolved in. So we can just call this X, and then 20 grams on the bottom as our whole, and then times 100. And now we just solve for X. And so X ends up being 0. Oops, that's a bad X. So X ends up being 0.6 grams. And we can see here, check. Yes, sir. All right, number 9, identify the type of chemical reaction represented by the balanced equation. So we have a compound here, right? And it breaks apart into 2 smaller parts. And so that is a clear indicator of decomposition. Boom. All right, number 10, calculate the percent error of the student's experimental result. Need the correct numerical setup and calculated result. All right, so the student measured, had an accepted value of 20.9%. So that's what he was supposed to get. They did an experiment and they got it to be 21.4%. So the equation for percent error is just measured minus accepted over accepted times 100. So like I said before, it's a very heavy on plugging and chugging with equations, but you should get positive 2.39%. All right, number 11, determine the total number of moles of oxygen that completely react with 8 moles of C2H6. All right. So if we had 8 moles of C2H6 on this side, in this equation it shows 2 moles, all right? And so we're trying to find the number of moles of oxygen. So for 2 moles, so 2 moles of C2H6, this reacts with 7 moles of O2. So what happens if we bring this up to 8 moles of C2H6? Well, that's a factor of 4, right? So this increases by 4 right here. And so we can pretty safely assume that this will also increase by 4. So what is 7 times 4? That is 28. So we are ending up with 28 moles of O2. And boom. All right, number 12. What is the gram fluid mass of CaCO4? Um, and then that weird symbol 2H2O. So this symbol right here, that little dot, I'm not really sure what to call it, but essentially what you do here when calculating the gram fluid mass is that is the indicator of a plus. So it's sort of like combining these two compounds together, but you can see like the 2 would apply, like you have 2 full H2O molecules, and so what you would do is just calculate CaCO4 together and then add that to 2 times the gram fluid mass of H2O, which I'm pretty sure is 18. So we would get something like this, and our final answer would be 172.2 grams. All right, number 13, given the compound C4H10O8, calculate the molar mass of the compound. All right, so molar mass, pretty straightforward. Just calculate the gram fluid mass of 4 carbons, 10 hydrogens, and 8 oxygens, and then combine them together. And so we should get 186 grams. Calculate the number of moles in 17.7 grams of the compound. So if we have 17.7 grams, we can just set this over, that's ugly 7, put this over 186, right? Because that is the molar mass, which is also the number of grams per mole. And so we should end up getting, boom, 0.095 moles. What is the empirical formula? So what is the most condensed version of C4H10O8? Well, let's see what we can do here. What is the common factor between 4, 10, and 8? Well, that would be 2. So we get C2, H5, H5, and then O4. And since 5 is odd, there's no common factor between these guys. So that is our empirical formula. And that does it for the review of moles and stoic. So yeah, very heavy on the plugging and chugging of equations. Kind of repetitive, but hope you guys learned something, and thank you for watching.